The aim of this clip is to explain 1. What recipes are, 2. What's the relation between product recipes and job recipes, 3. Why recipes are so important, 4. What's the structure of the recipe form, and 5. What's the underlying structure of recipes that's based on machine types and machines. Let's begin. Recipes are the basic instructions and ingredients for manufacturing a product. Recipes define which parameters and materials are involved and required in production. Both the parameters and materials differ between products. For example, products based on mixing multiple materials per a known formula in assembly lines will have different definitions than products based on a single material manufactured via CNC machines. It's usually the responsibility of planning and engineering specialists to design and improve the product recipe. All products and jobs in the system have a recipe. A product's recipe is the primary recipe. Therefore, when creating a job for manufacturing the product, the job's recipe fields are populated with the values set for the product recipe. You can then adjust the job's recipe values to meet the specific context it's running in. For example, the cycle rate might be different if the job is running on a slow machine. If the product's recipe isn't maintained in Mantix, the initial job recipe can be populated with values set elsewhere, such as third-party systems. This doesn't mean you can't adjust the recipe. You can use other reference recipes within Mantix. For example, Mantix offers the option of using the values of the last most efficient job that was run for manufacturing the product using the same mold and the same machine. Other reference recipes are alternative recipes, recipes that were set and used in the past and saved for reuse. Regardless of the recipe's source, you can also combine, first apply a reference recipe and then tweak some of the values to match the specifics of the job's context. It's essential that you update the values in the job recipe to accurately reflect the target values used on the production floor. The real-time data collected by sensors is measured against the standards set in the job recipe, which means that these recipe values are used for calculating the job KPIs, such as machine availability, cycle time efficiency, OEE, material efficiency, and other production performance indicators. For example, if the value for cycle time is incorrect, the derived performance calculations will be incorrect. Production performance indicators are the beating heart of the system, so now you understand why recipes are so important. For updating the job recipe values, it's recommended you understand the structure and options of the recipe form. It's divided to two main sections, production parameters and material planning. Material planning includes one section with channels reflecting material inputs calculated by weight, and another section with channels that reflect those material inputs that are discrete, countable units. When using recipes that are enabled with batch management and traceability functionality, the recipe has to be continuously updated, otherwise consumption tracking will be incorrect. For those tinkering under the hood, production parameters, channels, and splits are all configured at the machine type and machine levels, and again will reflect the expertise of the planning and engineering specialists.